Good afternoon. Thank you for staying for my talk. I was just running from the building C to make sure I make it here on a time. I had a Project Lightning talk there. Gladly, I made it on the time. It's also very cold out there. I live in the south of the India. And as a person who lives in the south of India, it's very, very cold out there for me to manage. Only I know how I'm managing it. But yeah, I was able to make it to the conference itself, which was good. Now I'll talk about the case study today, which is like managing millions of volumes at a scale. And how do we do that? So if I give the introduction, I'm Yash. I work at DigitalOcean as a developer advocate. And with me today, I have a co-speaker, Anand, which is not on the stage, but he recorded a video for you all. He's sorry that he was not able to make it today as well. But he recorded a video where he will share his part. We will talk about, so I'm also a maintainer of a project called Mishri. It's a CNCF project. So that's the part of the introduction. Let's come to the part of DigitalOcean storage solution. Before we dive into what I'm going to talk about, what the case study is, I just want to give you an overview what DigitalOcean gives an offering, which is called storage solutions. So in storage solutions, we have two storage services for DigitalOcean, which is the space object storage. Space object storage, which is kind of like a S3 compatible storing services, and DigitalOcean stores large amount of data from the customer itself. Next one is the volume. So DigitalOcean also provide the volume-based storage as well for droplets, and they also have a lot of storage and the number of instances for it. Now, we got the idea, okay, what are the DigitalOcean services that we provide for the part of the storage. I just want to give you some idea of the scale that I'm going to talk about. So DigitalOcean have more than 24,000 of block storage and thousands of object storage. I was not able to actually get the exact number from the engineering team, but I got the rough idea, which was like the object storage number is more than like 3x than the right now what we have for the block storage. So it's kind of at a scale as well. And if I talk about the clusters, we have 13 plus clusters in 11 plus regions. And these are in all over the world in our data centers to help ensure that services are able to run, which helps actually for our customers to create these object and block storage. Now we get the idea what I'm talking about and at what scale I'm trying to talk about. So to adopt this, we used to have a rancher to manage our clusters, and the storage team used to do that. But they adopted ArgoCD to do the CD part of all this deployment for our storage platform. So this is the case study for ArgoCD, how the DigitalOcean object team use ArgoCD to ensure all of the services are able to run properly, and we are able to manage at such a scale without any downtime. I just want to give one highlight as well, that ArgoCD actually helps us managing all the data plane and control plane, all of these clusters. The cluster that I talked about, all of the data plane and control plane are managed by the ArgoCD. So what we will be talking about, why we pivot to the ArgoCD for the storage team. We will understand the architecture we adopted with the ArgoCD and impact it had in the engineering team. So for that, I'll start with understanding the architecture, and for that I'll ask Anand to present this, and I have to play a video. So I'll play the video, and hopefully it is visible for you all. And let me just start the video.
Hello everyone.
Can we increase the volume?
But I'm thrilled to join virtually. Myself, Anandhkumar. I'm from Storage Platform team. I wanted to share a practical case study today, not just about the tool, but about how we transformed the platform team velocity and developer experience at DigitalOcean. As our cloud offering expanded, so did our Kubernetes footprint. We went from few clusters to dozens. So we needed a solution to manage this multiple cluster, but felt simple enough for a platform team to manage while keeping our developer team autonomous and secure. we needed scale with simplicity. So why we choose ArgoCD? Before discussing about ArgoCD, I want to set some light about our current Kubernetes setup. So Storage is a bare metal Kubernetes platform managed by the Rancher, which runs on our GCP global control plane that manages multiple Kubernetes cluster, which is a downstream hub we call, globally across various data centers. So we needed a CD mechanism for this setup. We considered Rancher Fleet, Flex, and ArgoCD. Our previous experience with the Rancher Fleet is it is a selectively authoritative, meaning if a deployment bundle gets removed, it results in immediate deletion of downstream services. It also has a own failure mode of deleting its own bundles. Plus, the lack of surface metrics made the failure detection nearly impossible. This is where ArgoCD takes advantage. It has a true declarative state, meaning which it's tightly coupled with a Git enforcing the Git state. So even if someone manually changes the YAML file in the cluster, ArgoCD sees the drift and it immediately heals it. That consistency is non-negotiable for us. It also offers the extensibility with application set. Basically, we leverage cluster generators to generate application across various data center in number of clusters. I will talk more about this in our future slide. ArgoCD is graduated CNCF project, so it has active community support for the long-term stability. So our biggest architectural choice was to run a single highly available ArgoCD instance in a dedicated management cluster or GCP rather than one instance per cluster. So why centralize? Because simplicity of the lifecycle, managing one ArgoCD instance is simple compared to managing 50 for the platform team. It also provides a single pane of glass visibility into all the deployments. But there's a risk. Being a single introduces a single point of failure. So we handle this single point of failure using droplet anti-affinity feature, which is nothing but we schedule this virtual machine across various racks and this hosts our ArgoCD bots. So this is to survive in case of rack failures. Even after this, if ArgoCD goes down, the cluster don't just stop working, it just stop receiving the automatic updates. We also have the native backup and restore mechanism in case of DR situations. As we choose ArgoCD is the one that suits our needs, we wanted to fit it right in our Rancher cluster. So for this, we have written a small utility, which we call it as ArgoCD Rancher Sync. It's a Go application which authenticates with the Rancher API to discover the number of cluster it managed and add those clusters into ArgoCD cluster list. So now it's all integrated to deploy the applications. So how do we deploy one applications to dozens of clusters without copy pasting the YAML? So we leverage application set generator for this. So if you look at this sample application generate manifest, the platform team tags the registered cluster with a meaningful labels like environment, production, region is NYC3, and so on. And this application set uses a selector field to find all the cluster matching those labels. Then the template automatically creates a unique Argo application resource for every matching cluster with custom configuration based on the destination. So this is how our actual environment look like at a high level. In the left hand side, we have a GCP cluster which also hosts the ArgoCD that creates the app set that gets deployed in the downstream heads in the right hand side. So the result, a developer commits one application set file to a Git. The ArgoCD automatically spins off n distinct application targeting all the clusters that needed the application. This is the true meaning of scaling CD with simplicity. So we have multiple teams working on the same ArgoCD instance, like the block storage team, object storage team. So how do we ensure one doesn't step on other toes? RBAC is paramount here. We solve this problem using ArgoCD projects. ArgoCD projects are the security boundaries and guardrails for our storage team. We define a project with the three critical constraints, ensuring granular control: the roles, policy rules, and groups. So the role defines who can perform what actions on what applications, and the policy defines the action that can be taken. For example, a droplet storage team might only be allowed to deploy application from their designated Git repositories. So if you look at the image that I have attached, so the read-only policy have access to only read the application from the droplets namespace. And if the storage object admin has various access to object storage applications. So the group or the OIDC group names that are bound to a specific role, this comes from the Okta during the authentication process. So this is how the RBAC flow look like, which integrates with our existing Okta setup. When a user do the SSO, it logs in with the Okta that passes the OIDC group names in the header to the ArgoCD app. So we go beyond basic deployments. Once the application reaches the cluster, we need sophisticated continuous deployment strategies. This is where ArgoCD rollouts come into play. We majorly use canary deployment. So this comes with the power of pause. Basically, when a new version rolls out, so it increases the traffic to 10% and it pause and perform certain checks, like checking a error rate, HTTP latency. Let's say if error rate stays below 1%, it increments the newer version to, let's say, 50% and 100% and so on. But if it finds any issues, it automatically rolls back. This removes push and pray mentality. It enables progressive delivery, where the system makes a deployment decision based on the actual metric, not just a kubeAPI call. So now we have this ArgoCD that does all these things. Now who watches the watchman? So we manage the lifecycle of ArgoCD using our Ansible playbooks. We have a playbooks for installation, configuration, and secrets like registered cluster credentials using Ansible playbooks. Our Ansible code is stored in Git, which defines the desired state of our ArgoCD control plane. When we onboard a new cluster, we update our playbook, we run the playbook, and our control plane remains consistent and repeatable. This ensures we are treating ArgoCD itself as a code. Now I would like to invite Yash to take from here. Over to you, Yash.
Okay, thank you, Anand. I hope you were able to understand the thing. He put a lot of effort. He was keep calling me, is the video is good? People will be able to understand? But he did well, at least from my side. So yeah, he shared quite a lot of information. So what I'll do is I'll switch to the next slide. Can I do that? Okay. I have to switch to all the way down, which is, oops. Okay. So I hope you get the idea that the architecture is not quite that complex compared, because we have a single cluster in which we have a single ArgoCD instance, which we call a local cluster. And we have a downstream clusters, which are managed by that cluster. All the deployments or the workloads goes through the ArgoCD from the local cluster. He also described like why that was important as well for us. Now, I just want to give a few highlights on applications managed by ArgoCD. So some of the important applications that we have in every cluster are also managed by ArgoCD, which are like the global applications, like the security policies, CSI, CNIs, like the Calico for making sure that ArgoCD is able to communicate with all of the region cluster, but also making sure that clusters don't do the peer-to-peer communication as well. And with that, we do region-specific applications management with ArgoCD as well, like the ESO for our external secret operator. It helps to make sure that we have a secret for region-specific, and the Fluentd to make sure that all the data goes to a centralized place, which is the Kibana. and the Prometheus operator exporter. So these are all the region-specific applications are managed by ArgoCD as well in every cluster. And with that, I think Anand already explained what are the benefits of the centralized management of all the ArgoCD, why we chose and why we pivot with that particular architecture for our storage team. But you will not believe it that this is not the only team that uses ArgoCD. There is a lot in DigitalOcean. There are a lot of team that uses ArgoCD. This was the single case study that I just shared with you today in this talk for the storage team. Now, so far we have saw that our prior experience with the Rancher fleet showed our several limitations, and that's why we switched to the Argo, and why we went with the centralized approach, and how we are tackling the single point of failure to make sure that we have a reduced deployment time and single pane of glass, so we have all the single deployments from a single view. Understand the store kits and Rancher sync. If you miss the part of the store kits, I just will highlight again, which is like store kits, our internal platform, which is a bare metal Kubernetes clusters, help us to manage all of the DigitalOcean Kubernetes cluster all across the globe. Who watches the Watchman, which we also covered. We do that with the playbook. Now I just want to highlight the impact. This architecture helps us manage all the services runs on those clusters to ensure our customers are able to create the volumes and storage without any facing downtime. So ArgoCD makes sure the deployment goes through very well, and it helps maintain the region-specific applications globally. It also helps with reduce deployment complexity. So what I learned during my discussion with engineering team for this talk. So before putting out the talk out, I was talking with the engineering team, and honestly, this is the most of the information I was able to get out from the team. I was fighting a lot, like let's get it out. This is a great talk. Maybe we should get out and talk about it in the conference. And for the few months, I fight on that, and somehow I was able to do that. And whatever I learned throughout this preparation and when I was working with the engineering team, I figured that they were mentioning scaling with simplicity a lot of times. During my talk with Anand was also mentioning that scaling with simplicity a lot of time. And then I understand that, okay, scaling doesn't always mean complexity. It can scale with simplicity. So when I saw that, okay, we are managing at such a scale with such simple architecture, it's not that complex, right? We are doing that with simple architecture at such a scale. So that was quite interesting for me when I was working with them, and I just want to highlight it. Like sometimes we just need to make sure our business value comes out of it, and we are properly able to follow the right production rules and making sure our customers are happy at the end, right? So is this it? Yes, is this it? And why? Because DigitalOcean, we follow the scale with simplicity. At least that's what I learned from the storage team. And the take-home resources, there is a lot more detailed blog already out on the ArgoCD adoption. And this is only for the storage team. I'll definitely make sure we come out with the ArgoCD's more adoption case studies in DigitalOcean. There are several teams that uses ArgoCD inside the DigitalOcean. So if you want to get more information, if you want to connect with me or Anand, you can check out the blog. You can search on the DigitalOcean Kubernetes ArgoCD blog. You will definitely find it on the top. I'm pretty sure about that. And yeah, thank you, everyone. This was all. I hope you enjoyed the talk. I hope you learned something. And if you have any question, I'm already up for it. And yeah, if you have anyone have any question, I'm happy to take. Okay, I think there is no question. By the way, this was my first KubeCon NA talk. I'm so happy today. And thank you for joining my talk. Thank you, everyone.